How about now? How is the loudness? Is it too loud? Let me know. It might be a little loud. That's all right. We can handle all the technology. We can figure this out. We can make it work. I love the delay. Where you're like, is it working? Is it not working? Okay, good. It's working. Great. Okay. Oh man. So what happened was, our power went out, and my computer didn't like that very much at all. I didn't get a chance to sort of like properly shut it down. So the computer just went out. When it came back, I didn't notice, but all of the internal stuff had grabbed the microphone on my camera and not this microphone here. And so I recorded an episode. I recorded an interview, and the audio quality was garbage. So I'm going to have to fix that. And then I recorded Space Bites, and we finished recording Space Bites, and I passed it along to Anton, and he's like, we're going to have to redo this. The audio is just garbage. And so I had to read. So there is a version of last week's Space Bites that you didn't see, because I did the whole show twice because the audio messed up. And normally you notice, like I watch the waveforms when I'm recording, and I can look at it and go, okay, that looks okay. That's proper. And it looked good. And it's never tried to pass along the audio from my camera through the computer to me before. So I don't know what happened. It was frustrating, but clearly it messed up this streaming software. Who knows what other stuff it's messed up. Oh man. So frustrating. Anyone who's done any content creation, you've gone through this experience where you've made a thing and then you realize that thing has been destroyed. You didn't record audio for your video. You didn't record video. Your memory card filled up. Your computer crashed, and everything you did is just destroyed. Oh man, it is just so heartbreaking when you put all this work into something and it's just worthless. And you have to redo the whole thing again. So, hey, cool. So Visto, you actually got a notification. So I guess the thing works. I would have done the show with the medium of mime. Thanks, John. All right. So for those of you who are wondering what it is that you have stumbled into, this is going to be a live episode of the question show. So the question show that gets released every Tuesday, this is how we make it. You ask me the questions. I have no idea what it is that you're going to ask me, and then I just answer the questions as best I can. Now, bunch of things here. So go ahead, put your questions into the YouTube chat. I'm pointing as if like that means anything to you. The YouTube chat that's right over there. Go ahead, put your comments into the YouTube chat. We've got two moderators here, John Seffel and Zapfan. And they're going to be able to grab your comments, and they will put them into a database that I can see. And then I've got a list of the questions, and then I will go through this list of questions, and I will answer them as best I can. Now, we get way more questions than I have time to answer. So a couple of things. One is definitely don't ask your question multiple times. They'll ignore it. I'll ignore it just once. It's okay. We got it. It's in the database. It's safe. And then the other thing is that I'm just a journalist. I am not a scientist. And so I cannot give you informed opinions about things that have to do with anything, really. Although, sometimes I can be tricked into doing it. But in general, I try to resist. And so I can't give you an opinion. I can just report on opinions that other people have. I try to give emphasis to people who've never had a question answered before. So if you've never had a question answered and like something pops in your brain as you're watching this video, just go ahead, put it in. And if you're a first timer, I like your chances. And then obviously I'm running a sort of simulation in my mind of what have been in the recent question shows. And so if I feel like it's the same question over and over and over again, I may skip it for a couple of weeks before we kind of bring it back. I don't want people to be worn out. But obviously, Lagrange questions are always welcome. All right. Do I have a pop filter for my mic? I do. I don't have a pop filter. I have one of these. I do have a pop filter kicking around, but it's like it's this big machine that sits in front of my face, and so it's kind of tough for this. So, but I've moved the microphone down so that I'm not breathing right into it. I'm sort of breathing above it. So hopefully that'll be a lot better. Okay. So I'm gonna drink water, and then we'll get started. Oh, right. Just a reminder, this show is about 2 hours long. So we're going to get started now. The first hour will turn into the question show. And then the second hour, we call this overtime, where it's a lot less structured, free form. I try to get through the questions as fast as I can. Or maybe I'll just stick on one and just rant for an hour. You don't know. I don't know. We'll find out what happens. So just prepare yourself emotionally that this could last 2 hours. But you don't have to stay if you don't want to, especially if you're not enjoying yourself. All right, let's get into it. I am now Jon Stewart's warm-up act. So after this, you're going to watch The Daily Show. Okay. Now, I've got some prepared questions that I pulled from the YouTube chat. So I will process those first, and then I'll get on to your questions. So there are my colors, Chad. Enjoy. Live recording reminder. Yes, I am recording. Yes. Okay. Sod Kyle. Can we measure our velocity relative to the Earth? No, sorry. Sod Kyle. We can measure our velocity relative to the Earth, the Moon, the Sun, the Milky Way, but what is the biggest thing we can measure our velocity relative to? And do we know what velocity we are if we are sitting in a chair on Earth? Yeah, you can measure your velocity relative to anything you want. You can measure your velocity relative to the chair you're sitting on, and it's 0. You can measure your velocity compared to the space that the Earth is passing through, and you're traveling with the Earth at about 30 kilometers per second. You're rotating on the Earth at about 1,000 kilometers per hour. You're moving with the Milky Way as it is rotating. You're moving with the Milky Way as it's drifting through the universe. And so the largest thing that you can measure your velocity relative to is the cosmic microwave background radiation. And this is the first light that was let out into the universe. And these photons have been traveling for 13.8 billion years. But when astronomers measure this cosmic microwave background radiation, when they look in one direction, when they look in a different direction, they see a slight redshift for the ones that the Milky Way is moving towards, and they see a slight blue shift for the half of the sky that the Milky Way is moving towards, and they see a slight redshift for the half of the sky that the Milky Way is moving away from. And they can calculate this, and they get about 630 kilometers per second. And so just by sitting in your chair, you are moving 630 kilometers per second compared to the cosmic microwave background radiation. Captain Dick G's. So wait, we could use James Webb to see the moon landing sites? We know exactly where to look, so why haven't we done this? There's a couple of reasons. One is that you don't want to point James Webb towards the moon. James Webb is an infrared telescope. It has this gigantic sun shield that is underneath it, and the whole purpose of the sun shield is to put it in between the sun and James Webb. And in fact, the orbit that James Webb is at puts the sun, the Earth, and the moon all in roughly the same spot in the sky forever from the perspective of this telescope. And so these three bright infrared objects are hidden to James Webb. The light from the sun has to go through all of these layers of fabric through the sun shield to eventually try to warm up the telescope. And so the last place that anyone using James Webb wants to look is in the direction of the sun. They spend billions of dollars so that it will never have to experience the sun. It is always in the coldest, darkest shadow that they could put together. Could James Webb see the moon landing sites? No, they're too small. But you don't need James Webb to do that. What you need is a spacecraft that is orbiting the moon. And in fact, there is one. NASA's Lunar Reconnaissance Orbiter has been orbiting the moon for well over a decade and flies within just dozens of kilometers of the surface of the moon and has imaged the entire lunar surface down to like less than a meter resolution in some places. It's incredible how much data we have about the surface of the moon. And in 2011, sorry. And in 2011, NASA had to change the orbit of the Lunar Reconnaissance Orbiter, and that allowed them to get some even closer shots of the lunar landing sites. And so they were able to come within 22 kilometers of altitude above the moon landing sites. They were able to image each one of the landing sites, all 6 of them. And the resolution, the things they were able to see from the mission are incredible. They could see the lunar landers. They could see like the various experiments that had been set up on the surface of the moon. They could see where the little lunar rover was in the later missions. They could see the footprints of the astronauts as they were walking around on the surface of the moon. And so that is like, those are going to be the best images that we have of the lunar landing sites probably forever. Like unless somebody goes back and actually revisits the sites, images from orbit they're just amazing. Peter Monahan, so I have a question that is $785 characters long. How do I post that question? Like, I don't know, but like short questions are better, please. Like I can't hand, I avoid long questions. So if you're gonna ask a long question, I'm not gonna probably take it on. I want short questions. Like, can you imagine like I have to read out the whole question? It'd be like an hour. Boboblio 4002. The moon regolith is known to be really rough on space equipment, plants, and lungs. Is there some kind of device like a rock polisher that could be used to make it safer for things like plants? Yeah, you're exactly right that the regolith on the moon is a very hazardous substance. What it is the pulverized volcanic rock left over after billions of years of meteorites of varying sizes have smashed into the surface of the moon and just broke it up into smaller and smaller pieces. Now, we have similar material here on Earth, pieces of sand, things like that. And you even have this on Mars, that you've got the pulverized fragments of volcanic rock on the surface of Mars. But the difference is here on Earth, we have wind and water erosion. On Mars, you have wind erosion that sort of takes these jagged pieces of volcanic rock and sort of wears the edges off of them. But on the moon, there is no erosion. And so all of this stuff is sort of in its perfect, sharp little jagged state. And when the astronauts went to the moon, they realized that this stuff is a lot trickier than anyone had ever anticipated. You see pictures of the astronauts, and they weren't out for very long, and they are just covered in this dusting of this regolith. They found that they were immediately getting irritation in their lungs when they were breathing it in. It caused irritation in their eyes. Now, the good news is there was no long-term problem for the Apollo astronauts for the short amount of exposure that they had to this regolith. But we know that there are substances that are very similar, like asbestos and other things, that will cause very long-term damage to astronauts. So like just dealing with the regolith, keeping this regolith out of the habitat is going to be really, really important. But the point you're making is, well, what about plants? Like, aren't we going to want to grow stuff in plants? In fact, a bunch of experiments have been done here on Earth where people have tried to grow plants in both simulated lunar regolith and actual lunar regolith. And they found that it works, but the regolith has no organic material in it. And so the plants will sprout, they'll grow for a little bit. In other words, like the roots can grab on to the parts of the regolith, but it's not actually deriving any nutrients from it. And so the plants will sprout up and then they'll die because there's nothing to go with. But it didn't seem like there was a problem for like the jagged shape of the regolith. And if anything, the plants are going to act like a form of erosion. And so if you did bring in some regolith, mixed in a bunch of organic material, made it wet, planted plants in it, then you're going to find the stuff is going to get safer and safer over time. That said, like if you bring this stuff in and you're gardening in it, then it's going to kick up dust. The dust is going to go into your lungs. The dust is going to go into your eyes, and that's going to be a problem. And so you're exactly right that probably the solution is to, when you're going to bring in the regolith from outside, you're going to mix it in some kind of water solution. Either just mix it up for a long time until it wears down a little bit, or maybe you're going to put in some kind of material that it's going to rub against, that's going to help take off the rough edges and smooth the stuff out. But you do not want to have clouds of lunar regolith in the, inside your research facility for any length of time. And this right now is probably the largest unsolved problem in having people be on the moon. I mean, we know how to deal with radiation, stay underground. The low gravity, I mean, don't stay there for very long. Temperature, pressure, power is going to be issues. But how do we deal with the wear and tear on every piece of equipment that's going to be experienced by, thanks to this lunar regolith? We still don't know what the solution to this is. All right, so those were the prepared questions. Now I'm going to answer your questions. L. John Keller II. Do you think that all-in-one smart telescopes like C-Star, Dwarf 2, Vaonis, Unistellar, and so on are the future of amateur astronomy or a passing fad? So I've had a chance to use one of these, which was the Vaonis telescope, and it was amazing. Like, these smart telescopes feel like magic. You take the telescope, you put it down, you pair it with your phone, it looks up into the sky, it knows where it is from your GPS, it plate solves some stars on the sky, uses that to figure out like what part of the sky it's looking at, and then you just say, I want a picture of Andromeda, I want a picture of M33, whatever. And it just goes ahead and gathers pictures. It uses, like, instead of it being like a telescope you can look through, it has a camera that actually records images and then stacks them up the way astrophotographers do. And even in light polluted skies with one of these telescopes, you can take pictures of the night sky. So they're absolutely not a fad. And I think, some of the fundamental technologies that have been incorporated into them just solve some of the greatest problems that anyone who has owned a previous generation of telescope has dealt with. And that is that these things are so hard to align that if you have a manual telescope like a Dobsonian, it's great, you pointed a thing in the sky, but if you don't know where the thing is, then you're going to want some kind of go-to mount. But the go-to mounts, you can spend half an hour, or forever attempting to polar align your telescope and never get it lined up perfectly. And so you got friends come over and like, oh, there's Jupiter. Let's take a look at Jupiter. Okay, fine. You're going to spend all this time. I'm almost there. Why doesn't this work? It's awful. But these smart telescopes, they just take all that problem and just make it go away. The ability to be able to just let anybody do astrophotography is fantastic. So I think these are all definitely on the upsides. So here's the downsides that I think so far. The first one is these things are expensive. Like, some are cheaper, some are more expensive, but you are looking at, compared to a traditional go-to telescope, you're looking at a lot more money. And they have nice optics, they have a nice camera system in them, but they also have all this additional intelligence and robotics that makes the telescope work. And so just kind of size for size, you could spend more money directly and buy a nice telescope, a nice camera system, a really good mount, and you're going to be able to take better pictures. They're going to give you more control over it. And then the other thing is, like, they're not great for doing visual astronomy. You can do it, like you can go, hey, let's take a look at Jupiter, and then you can point at Jupiter and bring up pictures of Jupiter, but you're not looking through the eyepiece. And so if that's really important to you, then I think that's the thing you're going to want. I think the future of astronomy, of this technology, is to make the plate solving part, the simplicity of the go-to, what technology needs to exist in every future telescope from here on out. And it's sort of like the idea that I've always had is that you would have a mount that has its own little telescope on board. And all the mount does is looks around at the sky, finds the stars that it recognizes, and knows where it is and what it's looking at. And then you can put any kind of telescope on top of it, and then you can kind of get the best of both worlds. And, I'm sure people have already come out with this version of a mount so far. So, they always say like the best camera is the one that you actually have with you. And I think in astronomy, if you want to take pictures of the sky, like the best telescope is going to be the one that you're willing to use quickly. And if you find you've been struggling with the go-to telescopes in the past, these things are fast. You set it up, you're taking pictures, you're having a good time. And so I think that goes a long way for them. So I think they are the future. I think we're in the initial stages of this. But I think we're going to see some version of this technology in every major consumer telescope into the future. Chance Fox, did you ever get an update on the limits of James Webb? Nope, not yet. I asked him in the interview like a couple of days ago. So no, it's going to take us a couple of years before someone writes a paper on it. Briscoe Rob, when is the universe expected to bounce back like an elastic band? Well, we don't know what the future holds for the universe. One of the big questions that astronomers have been asking is, what is the fate of the universe? How will it all end? And so one possibility is that the universe is expanding and then it's just would slow down over time and eventually coast to a stop. Another possibility is it'll be expanding, it'll slow down over time, but it'll never reach sort of the stopping point. And the other possibility is that it will slow down over time and then the mutual gravity of all of the galaxies will pull it all back together again, and then you will get this, as you said, this sort of elastic band rebounds. And so everything would sort of run in reverse. The temperatures would get hotter and hotter and hotter, and eventually you get some version of another Big Bang, or maybe it just smushed together again. And this is called the Big Crunch. And so back in 1998, astronomers wanted to find out what was going to happen. And so they used this cosmic yardstick. So they used this cosmic yardstick of type 1a supernova, which are a kind of supernova that explode with exactly the same amount of energy. And if you know how much, when you measure the brightness of one of these supernova, then you know how far away it is because you know how much energy was in the explosion. And they did this really precise measurement of all these supernovae. They wanted to know, is it going to crunch back together? Is it going to slow down and just reach a stop at infinity time? Or is it just going to keep expanding forever? And what they found was that, in fact, the expansion of the universe is accelerating. So it's doing none of those three things that they were expecting. It's actually getting the separation between galaxies is growing and accelerating over time. And this is dark energy. This is this discovery, this observation that the universe is accelerating. And so now it's not expected that the universe will ever collapse back down and like an elastic band, that it will continue to expand, that it will get less dense over time. Eventually, all of the galaxies will run out of gas, all the stars will die, the black holes will evaporate away, and the entire universe will cool down to some just average temperature. And this is known as the heat death of the universe. And this is the way the universe is expected to end. Thwaites awaits. Would you consider doing a crossover episode with Kyle Hill about NASA ESA's nuclear RTG power sources? Yeah, that guy really likes nuclear uh, reactors. Yeah, that'd be great. I'd love to do an episode with Kyle. Um, Disinclined to state, no deadly perchlorates in lunar soil. Not that I know of. I don't think there are perchlorates the way there are on Mars, because I think they're coming out of the atmosphere. Indoor teacher, what are your thoughts on the samples from OSIRIS-REx? So the OSIRIS-REx mission has a special plate in my heart. Plate in my heart? So the OSIRIS-REx mission has a special place in my heart because I watched the rocket launch. When you go onto my channel, the introductory video is me and my wife and Chad going to Cape Canaveral to actually watch the OSIRIS-REx mission launch. It was amazing. First and only time I've ever seen a rocket launch. And now here we are at pretty much the end of the mission part where the samples have been returned to Earth, and they've been able to finally get the sample capsule open and be able to distribute them around the world. And the plan was that they were going to get about 60 grams of material from asteroid Bennu. And in reality, they got about 250 grams of material. And so there's so much material. They're going to be able to distribute this to various labs around the world. They're going to be able to put this into museums at the Smithsonian. When I was in Tucson about 2 months ago, there was a whole exhibit where they were going to show you samples from OSIRIS-REx, but they hadn't been able to get the sample capsule open. And so there was like sample goes here, and at the it was at the Gem and Mineral Museum in Tucson. So I missed getting a chance to actually see them up close. So it's too early right now because they just got the samples open and they've just handed them off to various researchers. But we're about to witness the power of Earth's labs, where you've got scientists here on planet Earth with the best facilities at their disposal to be able to study pieces of an asteroid. This is like, people always ask me, like, why bother bringing samples back to Earth when we can go to another world? We can take a rover like Perseverance. It can carry a microscope and other stuff on board. But it just, like, a tiny little miniaturized mass spectrometer just does not compare to a facility that is as big as a lab here on Earth, with scientists able to work with samples, be able to modify and change, try different experiments. It's the scale of this is so much bigger. And so, it's so early right now, but like some of the initial ideas I heard from Dante Loretta I heard a quote from Dante Loretta. He's the principal investigator of OSIRIS-REx, that he thinks, based on the kinds of samples that they're seeing, that this might have been exposed to water in the past. And so maybe this was part of Earth, or some part of something that had water on the surface in the ancient past. And that would just be mind-blowing if that's true. So that would tell us about the early solar system in ways that we just never knew. So we are just in the early stages of this. And over the next couple of years, we're going to hear paper after paper after paper where people are announcing the things they found in the OSIRIS-REx samples. And then you take that idea and then you think about what is going to happen when we get our hands on the Mars sample. Like, it's one thing to have Curiosity and Perseverance rolling around on the surface of Mars, drilling into the rock and doing the best that they can, and to have those samples back here on Earth in the hands of scientists doing really deep science work on the samples. So I can't wait to hear the science from OSIRIS-REx, and I really can't wait for someone to bring some samples home from Mars. Abdallah, what is dark matter? Nobody has any idea. Astronomers can observe the effects of dark matter. They can observe how its gravity influences the motions of stars, how it distorts light, how it changes the way stars rotate inside galaxies, its influence in the cosmic microwave background radiation. Astronomers can see how blobs of dark matter are orbiting around galaxies. They can see galaxies that have only dark matter, galaxies that have no dark matter in them, and places where dark matter has been stripped away from the gas and dust. What is it? Nobody knows. Sorry, just looking for a question. Roadside rebels. Even with the damage to the helicopter on Mars, have they tried to fly it or just too much? Roadside rebels. Even with the damage to the helicopter on Mars, have they tried to fly it or just too much vibration, etc.? Yeah, from everything I've heard from NASA is that the mission is over. They're not going to try to fly it. They're done. And like, I think you've got always this balance. Like, do you want to push your technology to one final step to see what's going to happen? Right now, it's sitting safely on the surface of Mars. Maybe some future explorers are going to be able to come and find it and to be able to analyze the material on it. Perseverance can't stick around and I don't know, pick it up every time it knocks itself over on its side. Perseverance has work to do. And so it has to leave it alone now sitting on the sand dune. So NASA, looking at the damage to the rotors, decided it was unsafe to fly. This is the end of the mission. Robert Allen. Should there be two more Lagrange points perpendicular to L4 and L5? I'm trying to think how this works. Perpendicular. Like if you have L4 and L5, do you mean above and below? Do you mean on the other side of the... I don't understand the question. But it's a Lagrange... I want to answer the question. So maybe if you can give me more information, that would be great. Jesse Hardy, I heard that scientists said that all the planets around TRAPPIST-1 system might have lost their atmospheres a long time ago. Have you heard this? Yeah, well, we report on this for Universe Today. I guess I'll do this. All right. Jesse Hardy, I heard scientists say that all of the planets around TRAPPIST-1 system might have lost their atmospheres a long time ago. Have you heard this? Yeah, not only have I heard this, but I suspect you read this article on Universe Today or one of the websites that reprints Universe Today stories. Maybe phys.org. I believe the title that I came up with was, if there are any atmospheres at the TRAPPIST-1 planets, they're going to be long gone. And astronomers looked at the amount of radiation that's coming from the TRAPPIST-1 star, considered if there were atmospheres around the planets, ran a simulation, and found that within about 100 million years or so, all the atmospheres of all of the TRAPPIST-1 planets should have been stripped away. Is this the final answer? No. I mean, you need to have James Webb actually make those observations of the atmospheres around the planets at TRAPPIST-1, and also make tens of observations on other planets around other red dwarfs before we can start to really rule out this idea that red dwarf planets can have atmospheres at all. Right now, things aren't looking great. We know that there's no atmosphere around the first two planets orbiting around the TRAPPIST-1 star. There was another, a Gliese planet. There was another red dwarf star with a planet that has been determined that it doesn't have an atmosphere either. And so we're waiting for the rest of the TRAPPIST-1 planets. But like, I would not be surprised if TRAPPIST-1, D, E, F, all of them have no atmospheres. And if we get to a point where we've seen several dozen planets having no atmospheres around red dwarf stars, then I think at this point astronomers are going to say, okay, we can't look for life around red dwarf stars. It's too early right now. You know, we're still in this sort of in-between stage where we don't know and we're hopeful, but, you know, don't get your hopes up. Jay Cross, can you get a guest who can talk about what the muon collider might discover? Yeah, I'll try, Jay. Jesus Solus. If satellites are the first products being used to build a space economy, what would be the next product? Is there anything specific that you're interested in seeing while a space economy develops? That's a really interesting question. And I think this sort of leads on to the interview that I did with Zach and Kelly Weinersmith about how ideas for a city on Mars or on the moon or things like that are very far-fetched. We absolutely know that satellites are a profitable business. Starlink is going to make so much money. There's tons and tons. Weather satellites, Earth observation satellites, communication satellites, navigation satellites. There's all kinds of money-making reasons why you would put satellites in orbit around the Earth. But then what comes next? And that's a really interesting question. Like, when you think about all of the ideas that Zach and Kelly analyzed, none of them really seem to make any sense. Like space power, probably infeasible. Asteroid mining, unfeasible for a long time. Space-based manufacturing, you know, we can manufacture stuff down on the Earth. So space tourism, you know, there's only so many billionaires on Earth who are going to want to go and float around in zero gravity, and they won't be able to bring the prices down for regular people to be able to do it for a long time. So that sort of taps out at a few thousand people a year. What's next in space? And I don't know. So what I think that we will see is that we will see things like, say, the Deep Space Gateway, and we will eventually see a lunar base set up by NASA or maybe an international collaboration or the Chinese. There will eventually be multiple lunar bases, and they're going to require supplies. They're going to require water and other stuff. And so maybe there will be commercial contracts for partners to be able to bring material to these lunar bases to keep everybody alive. There will be commercial contracts to send supplies to and from the moon. But I can't think of reasons beyond that. And so I guess infrastructure, if I was just to like put a catch-all term, it would just be infrastructure. There will be telecommunications relay satellites farther out in the Earth Moon area. There will be asteroid mining, maybe to bring supplies to the moon research station. So it's going to be like supplies for whatever stuff that we have in space. So I'm going to call it infrastructure, but it's going to be not very much for a long period of time. And like, I know that's not the science fiction future we were all hoping to hear, you know. We want to be able to hop into our starships and fly from world to world and get off and, you know, hang out under alien skies. But yeah, I just don't see a lot of things that are going to make us money in the medium term. There we at 41. chaos scientist or rapper. If we set off an ungodly amount of explosives on the moon, could we create a pseudo atmosphere? Because we could then start some kind of erosion. No. Yeah. So I'm not sure about setting off a bunch of explosions on the moon. Like you would if you set up a bunch of bombs on the moon and you exploded it, then you would create this giant cloud of regolith around the moon. In fact, like when a rocket lands on the surface of the moon, the dust that it kicks up goes into orbit around the moon and can actually be damaging for any spacecraft that's going to attempt to land on the moon. You got to wait for that dust to settle back down before you attempt to land on the moon. So that sounds dangerous, but, and I love this, that you could take like a comet or something and you could supply atmosphere to the moon, with magic, who knows how. And you could build up an Earth's atmosphere worth of just air at the moon. And that would last for about 10,000 years. So, every few thousand years, you would have to then top it up a little bit, which, I'm sure it's a ludicrous amount and who knows if we'll ever do something like that. But wouldn't that be so amazing that we would have the Earth with its atmosphere and oceans and all of that, and then you could have the moon with its own oceans and atmosphere. Like as long as you keep that thick atmosphere, then the place is going to be great. And you're exactly right. You would get erosion. You would get, now it would be weird because like a day is 14 days long and a night is 14 days long. And so it would be very cold on the far side. Like it would be still a weird place to go. But, once you got an atmosphere set up at the moon, it would last for a long, long time, for as long as like human society has been around. So people always ask me like, where should we terraform first? And my answer is always the moon. Adam, Fraser, I know you can tolerate animation. So have you heard about the show Scavenger's Reign? Please look it up. It's part normal show and part alien biosphere doc. You will love it. Scavenger. Let me just put that up in a browser right now. All right. Where is it? Where do I watch it? It's on Prime. Okay, done. That sounds great. Just to warn you, I'm foolishly watching One Piece, and so I'm in the 230s right now of One Piece. I've been at it since November. So I've got so I should have One Piece finished in about a year, but I'll stop and I'll watch the show because you're right. This sounds right up my alley. This sounds great. Thank you for the recommendation. Sid Vicious, how can we trust the achievements of the Chinese space program and their contribution? Sid Vicious, how can we trust the achievements of the Chinese space program and their contribution to the scientific community if their space program and that is tied to the CCP government, which we can't trust? That's a tricky question. On the one hand, you have the Chinese government. And, I'll let you run whatever narrative in your brain you want about the Chinese government right now. But, I know the things that you're going to say. And then on the other hand, you have real things that are happening with China. They've landed on the moon many times. They've returned samples from the surface of the moon. They've landed spacecraft onto the surface of Mars. They are planning now to have humans set foot on the moon probably 2029. Like we're about 5 years away from the Chinese actually setting foot on the moon. And their plan is then to follow on with that with some kind of permanent base. All of this technology that's gone into sending humans to the surface of the moon, the plan is to send them to the surface of Mars as well, probably in the 2030s, 2040s. And all of the work that they're doing is proceeding according to schedule. They're hitting all of their deadlines. You're not hearing about the budgetary cuts that are happening in the US. You're not seeing the kinds of delays that are happening with other space programs. They have the world's largest radio telescope, which is with the FAST telescope. It's 500 meters across. They're building the world's largest steerable radio telescope. They're building a Hubble class space telescope that they're going to be able to operate near the Chinese space station. They're developing a giant neutrino detector in the Pacific Ocean. They are working on some really interesting cutting edge gravitational wave observatories, both ground-based and space-based, including like an interferometer that would work similar to the way LISA does. And it's not a completely separate world here. You have these collaborations. They're, if you're an astronomer that works in Europe or in Canada, or even in the US, but you don't have, say, directly government funding, you can get time on, say, the Chinese FAST telescope, and you can do collaborations with Chinese astronomers. There are tons and tons of research papers that I see every day in arXiv and various prepresses and journals, which are a collaboration between Western scientists and Chinese scientists. So there's a lot of collaboration and cooperation that is going on. And so I think that like the best thing to do is for people to work out ways to work together, to peacefully collaborate for the betterment of humanity. And that's going to require negotiation. That's going to require willingness to work across borders to figure out ways that you can improve our scientific understanding together. And I think that people hold these just black and white views about things. And I don't think it's realistic. Like, I think, you could have problems with a country's government, but you would have no problem with the people. You would love to spend time with the people, and they would be warm and caring and let you into their home and show you the utmost hospitality. And that's the kind of experience that you would probably have with the researchers if you're collaborating on projects together. So it's complicated, and I don't know what the answer is. I'm just a journalist. I will tell you what projects are being worked on in China as soon as I hear about them, as soon as they inform they lift the veil of secrecy and tell us what's going on. And I'll also tell you what's going on in other countries as well. And I don't think there's any simple way to proceed that isn't nuanced. Series K Leaf, 3 Bodies starts soon, the 10-cent version. Are you talking about the one on Netflix? Bravo 01, can we have Fraser with a Joe Rogan episode? Yeah, that'd be fun. Toomby, what are the chances that dark matter is just gas and dust that we can't see? Almost zero. Like, if you take the mass of a galaxy, like the Milky Way, and then you multiply it by 10 so that you account for the dark matter that is interacting. And when you think about how we can look in the galaxy and we can see the reserves of gas and dust, we can actually measure the signal that's coming from gas and dust. How could there be 10 times as much gas and dust in the Milky Way than what we can see when we can see gas and dust? So you can pretty much rule out that it's gas and dust. And we know that when gas and dust, especially one that is 10 times the amount of the mass than of the stars, it would interact in ways that would heat up, it would glow, we would detect it in X-rays and a lot of different wavelengths, and we don't see that at all. Now, and I don't know why, but people really are bothered by this idea that there is an invisible particle that we can't see. But we've been through this before, the neutrino, that when scientists looked at the fusion that was going on inside the sun, they made the calculation to say, well, if this is what's happening with the fusion, there is this tiny remainder's worth of particles that must be getting out into the universe, and that we don't detect them. We can't see them with our telescopes, so they must not interact. And yet there has to be a lot of them that are coming from the sun. And so then they had to create these gigantic detectors of like enormous amounts of water. And then they would get like one interaction between a neutrino and one atom in this enormous swimming pool's worth of water every, I don't know, long amount of time. And from that, they were able to calculate that, yes, indeed, the neutrino exists. And yet a neutrino, I've said many times, you can have a neutrino go through a light year's worth of lead and not interact with a single atom of lead. Like, that's how little neutrinos interact with the rest of matter in the universe. And we can't see them. We don't see the light. And so, we know that neutrinos are there. We know they're real. In fact, it's kind of amazing. Astronomers have used the Ice Cube telescope in Antarctica to make an all-sky image in neutrinos. You can actually see the Milky Way because of this image in just neutrinos. And obviously the brightest signal in neutrinos is coming from the sun, but neutrinos have been detected coming from supernovae. So we've gone through this process before where there are particles that don't interact with regular matter that are incredibly difficult to detect. It just seems that dark matter is even harder, but it's there, whatever it is, or it's not there, and we just don't understand gravity at the largest scales, which is also fine. Either of those is just, or it's black holes, which would be even cooler. So, but yeah, we know that dark matter isn't the things that we know how to see. Sure, Mark. Will the public be informed if JWST suffers more damage? Of course. Astronomers who are using JWST need to know what are the capabilities of the instrument at all times. And so every time there is an impact on JWST, there is, from a micrometeorite, then information is relayed around inside the agency. It's publicly available. We know exactly how many impacts have happened so far, on which panels they've happened, the severity of the impact, probably the size of the particle. I could, as a journalist, or you could as well, contact NASA and find out what the current state of that is. And they have no reason to hide it, because like any astronomer who uses Webb and is expecting a certain capability out of the instrument and then notices that it is not delivering that capability is going to wonder what the problem is. And they're going to have to explain that it was damaged. Well, so you just explain that it's been damaged. So yes, I don't understand why people think that there would be some kind of secrecy. And also, like it's not like astronomers are like all work for NASA. Very few astronomers work for NASA. Astronomers work all over the world for thousands of different organizations, for research universities, for space agencies, for private companies, all kinds of things. And they are all working in their own way, observing the sky. It's kind of like, I don't know if I'm trying to think of an analogy here. If a bunch of people in a city decided to buy new cars, would the car companies inform the public? Like, the people who bought the new cars are going to inform the public. They're going to tell their friends they bought a new car. Like, that information is just out in a million different ways. So there's no way to sort of, like, there's no central authority that is controlling it. And that's the way astronomers work. And in fact, astronomers won't shut up about the things they've found all the time. Like, the instant anybody finds anything, they're contacting their colleagues. They are posting papers in journals. It doesn't go anywhere near the government at all. Like you get a private, say, like a university, say a Harvard. Harvard has an astronomer. The astronomer books time on a telescope run by the European Southern Observatory. So it's a European collaboration. The telescope's located in Chile, and the astronomer is in located in Boston. And then they discover a new kind of supernova. And then they write up their paper and then they put it out on the internet immediately. And then they submit that paper to a journal that is operated out of England. Right? It's like this complex web of interactions. There's no sort of single party that's able to suppress anything. So, yes, if life was found in the universe, the public would be informed. If an asteroid was inbound to Earth, the public would be informed. And if there's any damage done to James Webb, the public will be informed. Because it'll just leak out from every orifice. Metaphorically speaking. Chance Fox, do you know if Spin Launch built their next scaled up version? Not that I know of. I keep asking someone from Spin Launch to do an interview, and they keep not replying. Oh, Thwaite waits. That's a great question. What's your favorite achievement of the Canadian Space Agency that isn't the Canadarm? Oh, you took my answer away. That's not fair. There isn't much. I mean, we have some amazing astronauts, I guess. Let's see this one. Whoa, it's 6 o'clock. All right, one last question. JLab63, is a nuclear ion engine a thing? Can it be a thing, or are they separate? Nuclear, thermal, and ion engine. Yeah, a nuclear ion engine is theoretically a thing. And you're right, they are separate things. So on the one hand, you have a nuclear reactor, some kind of fission reactor that is putting out kilowatts of electrical energy. And then you have an ion engine, and the ion engine is using electrical energy to accelerate some kind of propellant up to high speeds, and they use that for propulsion. And so normally ion engines are limited by the amount of electricity they can get, the size of the solar panels. And so they're incredibly efficient, but they don't put out a lot of thrust because you've got solar panels, maybe you're getting a couple of 100 watts of energy that you're using, you're accelerating ions magnetically out the back of the spacecraft, you don't get a lot of thrust. But if you put a nuclear fission reactor onto your spacecraft and it is generating kilowatts of electricity, I mean, I've heard estimates as high as like 1,000 kilowatts. So there's some very powerful potential. Let me find out what's the, hold on, I'm gonna get the right answer here because there are 22 nuclear reactors. Space. I want to find out how much power they had. 100 kilowatts. Like, what did the Safe 400 have? 400 kilowatts. Okay. Oh, yeah. I guess it's right there in the number. So you can have fission reactors that are 100 kilowatts, 400 kilowatts, just like orders of magnitude more electricity than you would have from solar panels. And so you can have bigger ion engines. They can produce more thrust. You can have multiple ion engines, and you get a much more change in velocity. So there have been some missions in the past that considered this idea. There was an idea for sending a mission that could fly to all of the moons of Jupiter, could just go into orbit around each one, analyze the moon for a while, fly out, go to the next one, analyze the moon, fly out, go to the next one. And it would have used this idea of having a fission reactor bolted on with an ion engine. And I can't wait to see if somebody, like if we do get a nuclear rocket in space, I would love to also see some kind of, nuclear ion engine rocket. All right, so that's the end of this part of the show, the main show. Now we're going to move into overtime. But before we do, I've got to record a bunch of stuff. And so I apologize in advance, but I've got to do a little bit of administration. And you may enjoy it. I don't know. So here we go. And so it's going to take about 5 minutes. Okay. Let's see. Could James Webb see the moon landing sites? How fast are we moving compared to the universe? Can James Webb see landing sites? And will we ever find atmospheres around red stars? All right. How fast are you moving compared to the universe itself? Could James Webb see the moon landing sites from the Apollo era? Oh, what was the other one? All right. And what do I think about smart telescopes? All this and more in this week's question show. Welcome to the question show. Your questions, my answers, as always, wherever you are. Across my channel, if a question pops in your brain, just write it down. I will gather them up and I will answer them here. All right, let's get into the questions. You've probably noticed the Star Trek planet name that appeared above my shoulder in the first question. Of course you did. You're observant that way. This is a way for you to vote to tell us what you thought was the best question of the week. So watch the whole episode, but we will put the names of all of the planets down in the show notes down below. And at the end, just write down that name for the question you thought was the best. We will count up all of the votes and we will celebrate the winner. And so this week, the winner was for Rev MSJ, what would be considered an unequivocal biosignature. And I hope you all enjoyed the answer. And thanks everyone who voted. And so vote this week. If you want to support the work we do at Universe Today, consider joining our Patreon club. Your support lets us have a minimum of ads and no sponsorship messages. Patrons get no ads on universetoday.com for life. Want the extra parts of the live stream that aren't in this edited version? You can sign up for a special patron-only podcast feed and get the overtime segments as well as other special behind-the-scenes episodes, including our monthly patron-only question show. Thanks to everyone who has already subscribed, and welcome to the recent newcomers: Lee End, Ryan, Benjamin Mueller, Tim Epperson, Sean Drummond, Trevor Stack, Sycom Nelson, Aaron Gabor, Zach Stoll, Chris Rote, Philip, and Frederick Wydron. Join the club at patreon.com/universetoday. All right, those are all the questions that we had this week. Thank you, everyone who asked questions in the YouTube comments, as well as everybody who showed up for the live show. We do the show every Monday at 5 p.m. Pacific time. So if you want to see the full 2-hour live question show, come join us every Monday. There's going to be a reminder somewhere here on the channel, so you can click to remind yourself when it's going to get started, and you will get an email notification from YouTube, and you can show up and join it. All right, we'll see you next week. I guess I don't have to have the all right, I'll see you next week, because I'm going to say that again. All right. So last week, I asked you to provide me with recommendations for YouTubers who are doing a great job of science communication, space science communication, and I'm still waiting for all of those because you haven't heard about it yet, but you will this week. So I'm going to provide another recommendation to you for a small channel that you should check out. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Andrew M. Gross, Antonio Lofilara, David Giltanan, Dougie Stewart, Dustin Cable, George, Jeremy Mattern, Jordan Young, Josh Schultz, Mark Anstis, Paul Rohrbach, Stephen Krasaki, Stephen Fowler-Munley, and Vlad Chiplin, who support us at the Master of the Universe level, and all of our other patrons. All your support means the universe to us. All right, so another recommendation for a small YouTuber, and at the time that I'm recording, she only has 8,380 subscribers on YouTube, and that is Dr. Maggie Liu. She is, or her handle is Space Mog, and her, let's see, and she's an astrophysicist who works at the University of Nottingham. She specializes in dark energy, but has a really great knowledge of all things space and astronomy. And I've done collaborations with Dr. Liu several times in the past. She's a terrific guest, can sort of answer any questions that I have about dark energy. And I do not understand why she doesn't have like a lot more subscribers. So if you want a channel for somebody who actually researches this stuff directly, I highly recommend you check out Maggie's channel. She's fantastic. So again, please let me know. I want to find channels that have less than 10,000 subscribers who you think do a really great job of accurately reporting space and astronomy information, conveying it, educational, whatever. I'm trying to provide a great list of people so you can know who you can trust. And so far, these are people that I feel that I can trust. All right, we'll see you next week. All right, so let me stop that. And let me stop that. Let me save it, and then we'll move into overtime. $248. Hello, patrons. This is your overtime audio for QA episode 248 that was recorded on Monday, February the 12th, 2024. All right, let's get into the questions. All right, what do we got? Only 76 unanswered questions, 80 unanswered questions. All right. Edward Glubin, what kind of life do you expect we could find on Europa? Do you think it's mostly microbial life or maybe in multicellular organisms? Obviously, we don't know if there's going to be any life on Europa. That would be awesome if there was. And the kind of life that we could expect to see is analogous to what we find at the bottom of the oceans around the volcanic vents, the black smokers. You have these volcanic vents at the bottom of the ocean where hot gases are making their way up into the ocean, mixing with the ocean water. It's very hot. So you've got like temperatures that are above 200 degrees Celsius right where the vents are coming out. And yet you have these colonies of microbial life that is around that. And then farther away, you have like temperatures come down merely to like 50 degrees Celsius. And then you have like worms and various kinds of crustaceans and things that are living off of this. And then farther from that, you have fish and so on that are feeding on this. But like in the ocean, you have like different layers. And so down at the bottom, you have this completely separate ecosystem that's cut off from the rest of planet Earth. But then farther up, you have fish at different levels, and especially all these ones that are adapted to living in the dark. But really, the big concentrations of life are at the top, where the sunlight can reach. You get plankton, that's the basis of the food web in the ocean, and then you have larger animals. And the problem is you're not going to get that on Europa. You're not going to get that infusion of energy that is coming from the top of the ocean. The only place that energy is being added into Europa is from the hydrological activity. And it really just depends on how much of this is going on. I mean, right next door you have Io, which is the most volcanic place in the solar system. So there's got to be some amount of volcanism that's happening on Europa. But the total amount of energy, and this is sort of the question, is how much energy is available to life in that atmosphere, how much energy is available to the life in the ocean in Europa? And it's not a lot. Like a fraction of what's available to life in Earth's oceans. And so if there is life, you're almost certainly going to see it huddled up around the hydrothermal vents, and then less and less free energy, chemical energy, and other nutrients are going to make it out into the surrounding oceans. And so, nobody knows for sure, but I always joke about European space whales, but I don't think we'll see European space whales. I think we will be lucky to see life huddled around the vents at the bottoms of the ocean. An hour of rapid fire answers. Is that what you want? See, that was a nice long answer, though. You don't want that? Okay, good. Okay, ring out of asteroids, Mars, Earth. So I'm going to gather up all of the TRAPPIST-1 questions here. There's no news on TRAPPIST-1. I'm sorry. So far, we have no report on TRAPPIST-1D, which is the first planet in the habitable zone. Marshall Eubanks, any more news on the Mars sample return? No news. Unfortunately, we're in this state of flux right now with the missions that we're dealing with, and with all of the cuts. I mean, when I interviewed Casey Dreyer a couple of days ago about what was the state of things at NASA, one of the questions that I asked him was, do we know if the cuts made by NASA JPL were like actually to shut down specific projects, or were they like a trimming across the agency? And I've talked to one person who is connected to people at JPL, and they said it's cuts across the agency. So all the different missions had to lay off, a few people to try and bring their costs down. But also you're going to see a lot of the not core tasks, they're going to lose a lot of people. So public relations, education, those things, it's one thing to tell people about the cool things that are happening at JPL. It's quite another thing to have to lay off people that are working on the Titan Dragonfly. So I think, so it's probably going to be tricky to see. Like I'll let you know if I feel like already I feel like I haven't been seeing a lot of news coming out of NASA since the layoffs. So we'll see. John Tupker, any recommendations that you provide for space news is very much appreciated. I can think of a website you might want to go and check out. Universe Today. What is the benefit? How far in the future do you think humans will be able to buy a planet? Like you could buy a whole planet? What a deal. George Tushev. I don't know if someone grabbed that. I'll get that question though. All right, so George Tushev. Sabina published about infinity microsingularity theory that can explain dark matter. Are you familiar? I'm not familiar with infinity microsingularity to explain dark matter, but one of the sort of interesting ideas for dark matter is primordial black holes. And so I don't know about if that's exactly the same thing that she's talking about. But I'm guessing, I haven't seen the paper, I haven't seen her video. I'm guessing what she's talking about is something new. So not the traditional idea of primordial black holes, which everyone has been talking about for a decade now, but specifically some new theory. And So I'll have to look into it further. But like the idea of primordial black holes, this has been around for a long time. That the early universe had folds of space that were so tight that you could just get black holes of all different sizes forming right at the beginning of the universe, and then they were present for the remainder of the universe. The smallest ones would have evaporated, but bigger ones would have stuck around even till now. So, and that could absolutely explain dark matter. Dark matter could be black holes, no problem. And it's funny to me that, people hear that, but like, oh yeah, okay, right, fine, black holes, that makes sense. An invisible particle that we can't see interacting with anything but gravity, that doesn't make any sense. But black holes, sure, that makes sense. Phil Leo. If first contact occurs, how do we communicate? They were peaceful, want to learn, teach us. What do you and Douglas Fekach Prez of METI, messaging extraterrestrial intelligence, say? Well, I don't know what Douglas Fekach says. We've reported on this quite a bit at Universe Today. There's been a lot of papers where people talk about how we communicate with extraterrestrial civilizations, and it's going to be tricky because, if you want to cause harm to another civilization, the lowest energy, the easiest way to do that is to send information. That you send a virus, a thought virus, that you say like, hey, build this cool machine. Here's an idea. It's a 3D printer that'll make you as much stuff as you want. You build it and it destroys your planet. And now the aliens have removed a potential future threat from the universe. It's a lot more complicated to try and actually go to the star system and destroy the planet where the aliens, where your enemy is. Much easier to just, send them a bad idea that they can then implement and wipe themselves out. There's always this idea of the dark forest from the three body problem. That the universe is a dark forest, that it makes the most sense to just hide. And if you do detect somebody else, get rid of them. And I don't like that, because you can't hide in this universe. We are giving off absolute signals of our existence in the way that we've modified the atmosphere of planet Earth, that we haven't figured out the biosignatures yet, but other civilizations with much larger telescopes, they can have a telescope that is 10,000 kilometers across, and they could be watching, they could see the cities on Earth. So they would know that we're here. So I don't think we can hide. And so I think because we know we can't hide, I think it makes sense to try to communicate with other civilizations, that there is more to be gained. But we definitely should be very careful about the messages that we send, to make sure, run them through a virus checker before we actually build the machine. Paul Shanley. Are lunar missions being planned to study the effect of electrical state changes on materials, electronics, biomatter as the lunar day-night terminator passes over? So I know what you're talking about, and this is really cool. So if you were like standing on the surface of the moon and you were watching it shift from day to night, that you would, I don't know whether you would actually see this, but there would be this sort of electromagnetic charge that would lift up the lunar regolith, that would cause it to hover a couple of meters above the ground and then shove it sideways as the terminator passes over. And I forget exactly what the cause of this is. Interaction between the lunar regolith and the solar wind, and I forget exactly what's causing it, and the various magnetic fields on the surface of the moon. And so like there's been a lot of research into this, and like what the underlying cause is and what it would look like. And I think the thing where it's sort of trouble for astronauts is that even if you've swept clean every little bit of lunar regolith on your roads, on your driveways, on your landing pads, on your equipment, that the moon is constantly going to be redusting everything that you've done. And so there's no just getting it clean one time, that even if you're not kicking up dust as you're walking around, it's still being distributed around just by being on the moon. Jesus the Christ, can you talk about the idea of using the ISS as a hub of a skyhook system? Specifically, would it be better used than simply dishing into the ocean? I mean, the problem is if you're going to try to use the International Space Station for anything, um, then you're going to have to maintain it. Then you're going to have to continually boost it. And parts of it are old, and the funding has ended will have ended for the International Space Station. And so nobody wants to fund it. Nobody wants to resupply it. Nobody wants to continue boosting it. So who's going to take it over? Is the problem first. And then if someone's going to take it over, then the question is, what could you use it for? Well, is the International Space Station the best platform for a skyhook? Probably not. Like, there's probably a custom built satellite that is designed to work as the anchor for a skyhook makes more sense than trying to attach it to the International Space Station, which nobody is maintaining, which is constantly, has a huge, like, it's like a sail interacting with the Earth's atmosphere. So it just doesn't make sense to try and use it for other purposes. So unless somebody wants to take over this thing and fix it up like an old hotel, they're going to ditch it into the ocean in about a decade. Peter Monahan, if time is space is matter, and black holes consume matter, then what happens to the actual time and space that has been consumed by the black hole? What fills the void? I don't really understand the question. Like, black holes take matter and they just compress it. So if, like, say on Earth, you're standing on the planet Earth and it has a certain density of 5 point whatever grams per cubic centimeter, and then if you just like turned it into a neutron star, well, the Earth would still be here. It would just be a couple of centimeters across. It would be teeny tiny and would have all of the mass of planet Earth just compressed down into this small space. And because of that really increased density, it would have a very highly distorted cause on space-time around it. And if it was rapidly spinning, it would frame drag, it would be twisting space-time around it. And if you went a little farther and you turned it into a black hole, it would still be there. And it would still be like all of the mass that was once in the Earth is now in a black hole, and now it has this event horizon around it, but it's all still going to be there. So I just don't understand the question, I guess. I'm sorry. And you gave a super thanks, so I want to try and give you an answer, but I don't know if I can. Man, so many questions. It's good. Doug Irvin. Fraser, why haven't we seen a gravitational lensing event with the naked eye? I mean, in theory, you could see a gravitational lensing event with the naked eye. It's just that when we look at the sky in perfectly dark conditions, we can maybe see 5,000 stars. And the chances that any one of those stars is going to have some object that it's going to be gravitationally lensing with is very remote. When you've got telescopes that are doing these surveys of the sky, they're able to see hundreds of millions of stars in the sky. And so your chances of spotting a gravitational lens are much higher with a much larger number of stars. Now, you asked about like an Einstein cross. And so an Einstein cross is only visible using the biggest telescopes in the world. Like these are gravitational lenses that are billions of light years away. And so, we can only see with the unaided eye, we can only see Andromeda. You could see M33, you could see the largest small Magellanic Cloud. That's pretty much it. And so you can't see off to billions of light years away where those kinds of large scale gravitational lensing are happening. Mike Wells, when will Artemis get people to the moon, in your opinion? Well, I don't have an opinion. I just report. And right now, NASA has said that they're going to push the Artemis 3 mission back to 2026. Could it slip again? Yes. I would not be surprised if the Artemis mission slipped again. This stuff is hard. And they're dependent on Starship being able to be successful. Rocky Giuliani, the core of the planet is magnetic. Is the Psyche asteroid magnetic? That's a great question. We don't know. Let's send a spacecraft like the Psyche spacecraft to go to the Psyche asteroid to find out if it's magnetic. Now, the reason that the Earth's core, or why the Earth has a magnetic field, is because you've got this spinning molten blob of iron in the middle of the Earth that is generating a magnetic field as it turns. And Psyche is just a few hundred kilometers across. It is, maybe it still has some molten metal inside of it, which would be awesome to see, like metal volcanoes. That would be so metal. But we may see ancient metal volcanoes on the surface of Psyche. I'm just going to ruminate on that for a little while now. Volcanoes of metal. That would be so awesome. Anyway, but it is, it's tiny compared to the core of the Earth. And so it has cooled down significantly. And so, I wouldn't expect it to have some giant dynamo going on inside of it. But I'm sure that if it has any kind of a magnetic field, Psyche will be able to detect it. It's one of the great reasons why this mission was chosen, because this is such a weird asteroid, so different than any of the other asteroids that we know of. Jonathan Good, in Don't Look Up, why did they try to redirect the comet to hit the moon? I mean, that's tricky. I mean, I think the whole point of the show was just that that we can face a threat and that we will be unable to take collective action to deal with the threat. And so Don't Look Up wasn't about an asteroid or comet. Don't Look Up was about us dealing with larger existential issues that require scientific consensus, and that there are moneyed interests to try and stop these things from being solved. And in the end, everybody died. Taylor Ginther, how do radio astronomers know where in the sky the signals are that they detect? So radio astronomers use radio telescopes, which look like big dishes, and they work like a satellite dish. So if you take a satellite dish and you point it in the sky where the satellite is that is communicating the television signal towards you, then the satellite dish picks up the television signal. And if you point the satellite dish a little away from where the satellite is, like literally when you take a satellite dish and you point it in the sky, you are pointing it at a satellite. There is a satellite up there right there in the sky. You can't see it, it's too far away, but it is sending you a signal. And so that's how you can detect it. And so with radio astronomers with these giant dishes, they are pointing the dish, the detectors that are connected to the dish, at a single spot in the sky. So they may know that there is a pulsar or some planet. They're going to try to detect a signal from an extraterrestrial civilization. And they know exactly where that is in the sky. And then they point the dish at that spot. And then they try to measure how much of a signal that they can detect from it. And for the longest time, you only got one tiny little spot. Like you would be detecting this one little piece of the sky. But more recently, astronomers can actually use their radio telescopes and have a larger chunk of the sky. And even like just in the last couple of years, radio telescope images are starting to turn into the kind of thing that you are more familiar with from X-ray telescopes or even visible light telescopes or infrared. There are these amazing images that are taken by the Meerkat facility, which is in Africa, South Africa, where they're imaging the core of the Milky Way and they in radio waves, and yet they see these amazing filaments of material that are located around the center of the Milky Way. And so radio astronomy has been undergoing a revolution fairly recently. Edward Glubin, what fuels your passion for space? I don't know. I've always been into space. It's weird. Like as a kid, as a 5-year-old kid, I had I don't know how many of you remember this book. It's called Our Universe. It's produced by Time Life Books. They had a bunch of them. Like there was one on undersea archaeology. There was one on animals. I forget all of the books, but the one that I loved was Our Universe. And I was like 5 years old, and I was just going through this book again and again and again, like just dog ear, destroyed the book. And then they came out with a later version that had it was updated like 1990ish, and they had pictures of Uranus and Neptune. I had the one that was pre-Uranus and Neptune. When I was like 1981, my dad had watched the Apollo landings, and he woke me up in the morning to watch the first launch of the space shuttle in 1981. And so we did that, and like it's just seared into my memory. We would go out and watch meteor showers. I lived in fairly dark skies, and we warm summer night, middle of August, we would go and watch the Perseid meteors with my mom and my dad. And so I love, my parents were into Star Trek, science fiction. They had a book shelf filled with science fiction. And when I was like 10 years old, I started to read through my parents' science fiction collection. I read stuff like Larry Niven and Ray Bradbury and Isaac Asimov. And I was just going through my parents' science fiction books. When I was 13, I bought my own telescope. I'd always been into space. I wanted a telescope, and so I bought one. It was a 4-inch Newtonian reflector. It wasn't great, but it was good enough. I could see the rings on Saturn. I could see the moons of Jupiter. And, my parents would have parties, and they'd have all of their friends over, like dinner parties and stuff. And I would set up this telescope, and then I would invite everybody out to come and look through the telescope, and I would show people the planets, whatever was up in the sky at the time. And then when I went to high school, there was a journalism program, and I joined the journalism program. And it hadn't even occurred to me that I wanted to be a journalist, but I just joined the program. I forget, maybe a friend of mine was in the program from a year before. Something. Anyway, I think it was because they had Macintosh computers, and I really wanted to use Macintoshes at that point. And so I wrote a column every month about what you could see in the night sky. And then I organized star parties. I've got the pin around here somewhere. Oh, is it handy? I don't know where it is. Somewhere around here, I've got the pin. Somewhere around here, I've got the pin from the star party that I organized, where 3 people showed up on Hornby Island, this island where I grew up on in the west coast of Canada. And then I stopped doing astronomy. I stopped being into I went to university for engineering. Then I left engineering to join a software company and sort of got into software development for like 10 years. And then just before, like a year, like 1999, I was working for I was working for a web development firm out of Vancouver, and we were doing a lot of like bank websites and power company websites and things like that. And I had all these ideas about how websites should work. And I would sort of explain my ideas to my clients, and they didn't believe me and needed more proof. And so I was like, okay, I'll pick one of my hobbies. And at the time, I was reading some books. I was reading Pale Blue Dot by Carl Sagan, which was just an amazing book. And I read The Case for Mars by Robert Zubrin. And so both of those books got me really enthused. I don't know, it's the equivalent of like nowadays, like someone's like stumbling upon some cool videos on YouTube and you just start binge watching. But we didn't have YouTube at the time. But I was like so excited. I'm like, okay, I'm going to make a website about space and astronomy and just run it on the side as my hobby. And then I was like having so much fun. I learned a ton about, and that was Universe Today. And I learned a ton about just how to maintain a website. And I had great advice for my giant corporate clients, but at the same time, I'm like, oh no, this is all I want to do for the rest of my life. And I think, the heart of what I do, the heart of like what I find so entertaining about this job is that I get to just follow my curiosity all the time, all day long. That's all I'm doing really, is I'm following my curiosity. Like obviously there's work to do, there's writing to do, there's people to manage, accounting to do, taxes, all that kind of stuff that go along with running a business. But at the heart of it is I get to just be curious. I get to see an interesting piece of research, and then I reach out to the scientists that did the work and ask them questions. And that is, I would say, that's what fuels my interest. We talked about this a couple of weeks ago in a different video. People have been asking me like, what do I think about all this YouTube retirement? And I think people don't spend enough time doing stuff for them, for what keeps them entertained, what fuels their own creativity and curiosity about whichever thing they do. You get to a certain point where you make YouTube videos and some of your videos are successful, and so you do more of that, right? Like, and then you get burned out. And then the algorithm turns, and now suddenly those videos that you used to make are no longer doing really well for you, and you're kind of trapped in this hole that you don't want to be. And I've been really fortunate and kind of obstinate, I think, pig-headed, which is that what I want to do is I want to talk to people and I want to learn things. And I know that it's not the right format. Like, I know it's not yes, me talking to somebody for an hour about some topic that I'm curious about isn't the most, like, I could do a 20-minute long video about Oumuamua or something like that, and it would do better to the YouTube algorithm. But I would be bored because I don't care. Yeah, it's funny. Like when I see people's feedback on the interviews and stuff, where you're like, oh, you're doing a bad job of interviewing the person. You should be letting them talk more, or, why are you taking time to understand it? Explain what he just said or whatever. And I'm like, I'm just talking to people. Like, I'm just having a conversation, and you can watch it or don't watch it. I don't care, right? It's not for you. It's for me. You get to come along for the ride, and I think that's the key. I think that's the solution. And so, we are now a month and a half away from my 25th anniversary of doing Universe Today. And I am enjoying this job as much as I ever did, more so. Yeah, I hope that answered the question. Mm, the Fulton Gap simulation explanation. This is from D Suits. I don't know this research. The small planet radius gap. Yeah, I don't know if there's any new research on that. Apologies. Pastel Assassin, any free to the public space satellites that you can recommend? That's an interesting question. So, are there any? I don't know of any satellites that the public can freely access. There are satellites, like I think about like the Discover satellite from NASA, and a lot of other, like the Hubble Space Telescope. I mean, the data that's coming from the satellites is freely available, but is there anything that the public can actually like control? I don't think so. There were plans from a couple of companies a few years ago to make a public, like a space telescope that the public could access, and you would pay for time on the space telescope and you would direct it to different targets, but I don't know whatever happened to that. Fates Awaits, a regular episode that's educated speculation on a topic, idea, field, and called The Universe Tomorrow. Um, so, like, I used to do a lot more topic focused work. Um, and I'm probably going to do a lot more of that in the future. Um, I mean, that's sort of used to be. If you go back to the early episodes, that's more about what it's like. I've done lots of like, here are all the upcoming telescopes that are coming, or here are a lot of the ideas in this field or that field. It takes more research, but I'll probably do a lot more of that stuff in the future. Um, I've really wanted to nail down interviews, and that's sort of what been my obsession for the last like maybe 2 years ago or so. Um, so yeah, I'm not sure sort of what the future holds. But like, okay, so here's my problem. I find that explainers on various topics are mostly just regurgitating Wikipedia, where you're just like taking some topic, like, what is Hawking radiation? And then you explain what Hawking radiation is. Um, but really, you're just kind of doing like a grade 8 um, book report on the Wikipedia page for Hawking radiation. And that's not journalism, right? Journalism is bringing something new into this world, that you are taking the knowledge of a specific researcher and you are asking questions, you're understanding, getting more insights from them, and then you are making this available to a public audience. And you are discovering new things that your audience wasn't aware of, that they couldn't have found in any other place in this world except for this one interview where they hear a Nobel Prize winner explaining how they found something, right? And that has to be, in my opinion, for the future of the work that we do, that has to be the foundation of what we create at Universe Today and the work that I do as we give you space news and so on. And so, there's sort of like, there's the interviews are one part of that foundation, and then there is the sort of the deeper digging that we do at Universe Today, and the team of journalists that work with us, where we're doing a lot of stuff now. Like a year ago, 2 years ago, we were doing a lot of like the kind of news that you would see everywhere, the press releases and the stuff that you're getting. But now I would say about half of those stories that we cover, you won't find anywhere else, because nobody has the resources to be able to cover this stuff. Like, we dig into journals, we look at pre-presses, we have scoops from people who give us information. And then the other piece of this is the interviews. And so then once we've got that foundation of original reporting on stuff that nobody else is talking about, and we've got interviews from the researchers who are doing the work, then that can be this solid foundation that then we can provide more layered information on top of that. that is explaining stuff, but it isn't just, hey, ChatGPT, please summarize this article from Wikipedia about Hawking radiation, and then write it in the style that Fraser Cain would give as a presentation on a YouTube video. I got to do that at some point. I've got to ask ChatGPT to write me a script in the style of Fraser Cain. It'd be hilarious. It'll be bad. NorCal Pacific, are any of your kids following your footsteps and going to the field of astronomy? Absolutely not. Nope. They have their own interests, their own hobbies. They both dig space, but no, they're their own people. I think one will end up being like in criminology or like the justice system or a lawyer or something, and the other one some kind of like mechanic or chemist, maybe, like really likes working with like physical objects. So Radis Norvicus, what is your opinion regarding free will? Do you think we have it or is it an illusion? Um, Man, I'm going to give you the classic journalist response here. I don't have an opinion. Some people think we have free will. Other people think we don't. Um, I think it, I mean, it doesn't, I don't think it matters, right? Like, we have to behave as if we have free will. Whether or not we actually do have free will, we may never know. But, um, the consequences of life are that you should behave like you do. It's like people ask that question about the simulation, right? Are we living in a simulation? Don't know. The simulation is good enough. There's no way we could know. But we definitely need to behave as if we don't live in a simulation. That reality is real until someone shows us otherwise. Till, we find out about the Matrix. Carmen Williams, do you think that NASA layoffs are a sign that the government is getting out of space? No, absolutely not. The NASA layoffs are a sign that Congress, that the US government is having a hard time agreeing on how to run the country. And so they are not doing a great job of delivering funds to the various agencies to fulfill the commitments that they want, that they've asked for. And so when you tell a person that you need them to build something, but you don't give them money to build that thing, don't be surprised if they don't build that thing. So I think that's the problem right now. And I think, a more smoothly run government would allow funding to reach the various agencies, and people could have a certain amount of certainty about the projects they're working on. And it's a lot easier to get an outcome when you can give the people working on that project certainty than uncertainty. Uncertainty is the worst. Like, I think of all of the things that we can deal with as human beings, we can deal with pain, and we can deal with discomfort, and we can deal with sadness, and we can deal with all of these things. But the one that we can never like be comfortable with is uncertainty. Uncertainty just, like, by definition causes stress, and that never goes away. I mean, like, for me, for sure, I know that uncertainty, you've gotta, your doctor calls you and wants you to call them back, right? You're like, oh, what is it? Right? Oh, I just want to tell you that you're doing great. Couldn't you have told me that originally? It's that uncertainty. And so just imagine a whole organization that is expecting to do some kind of work, but they don't know if the funding is going to come through. So, it is an ineffective way to manage an important operation. But I don't think that the government is getting out of space. Space is one of the few things that everybody agrees on. Everybody loves space. We all love space. On whether people are conservative or whether they're liberal, they love space. For, in some cases different reasons, but still, they believe that space is important. And so, no, I think space has a role to play in the future of humanity forever. And I'm sure that there will be funding for space from the US. But we've been in this unprecedented time, good times for 10 years where there weren't a lot of cutbacks. There weren't a lot of decreased funding. So people are unfamiliar with what it feels like to have the funding rise and fall. Pastel Assassin, what would be the biggest discovery in material science that would aid in space exploration? I think right now, there's a million things in material science, but a thing that I would be really interested in is coughing. Apologies. I'm gonna drink some water here. A thing that I'd be really interested in is perovskite, which is a kind of solar cells that are much cheaper to build. You can spray them on various surfaces on Earth. They are degraded by the Earth's atmosphere, but there's no atmosphere in space. And so that would be amazing if you could spray lunar regolith with solar cells and then it would start generating electricity. That would be great. And because, I mentioned this in a previous video, what you need is power. You need electricity on the surface of the moon to get anything done. So ways to generate electricity would be super duper. Oh, man. Wallamo, I've never heard of anyone saying, I hate space. Exactly. That's the joke that I always make. I'm at a cocktail party and someone else goes, what do you do? I'm like, oh, I'm a space journalist. I report on space and astronomy. Like, oh, I love space. I'm like, well, of course you do. Everybody does, right? It's like saying, I love puppies. So it's always sort of surprising to me when people write nasty things in the comments. And you're just like, wait a minute. You love space, don't you? Even though you're ranting about, I don't know, conspiracy theories or flat earth or whatever, the fact that you're so worked up is because you've always loved space and you space is the thing that you like the best. And at some point, somebody filled your head with nonsense and now you are experiencing grief and you're taking it out on me. Well, it's okay. Space will be waiting for you to welcome you back into the fold as soon as you sort of work through whatever these emotions are that you've got to deal with. John Pfeiffer, do you think any military capacity would be lost when ISS deorbited? No. I don't think so. There's Space Force has announced that their first Guardian is going to be flying to the International Space Station in a few months. And so that will be the first time that I know of that US military anything has been done on the International Space Station. Now, it's possible that there have been other experiments that have been done in the past. Not that, but I don't know of any. All right, one more question. It's only Kale. Any news on future islands of stability in the periodic table? No. no. There's thought there might be some future islands of stability, but like an island of stability in the periodic table is not, you're going to have elements that are going to last forever. It's that these things may last for millionths of a second instead of billionths of a second. And the thing you just got to understand is like supernova are the most powerful atom smashers that the universe has ever devised. You've got this matter falling inward at 70% the speed of light, crashing together. Think about colliding neutron stars. Whatever most heavy element that can possibly be manufactured are being manufactured in these things, but then they decay. And so, like, if neutron stars colliding can't make the heaviest elements, then they just don't exist. They, chances are, yeah, when two neutron stars collided, you had atoms that were much bigger, much more protons than anything that we've ever seen, but then they decayed. All right, so I want to wrap this up. I want to workshop something with you, and that is I want to provide an explanation of Hawking radiation that I'm sort of trying to reprogram, and I want to just let me know if this works for you guys. So you've probably heard this traditional idea that black holes evaporate. And the reason that they evaporate is that, according to Stephen Hawking, there are these virtual particles that are being generated right at the horizon of a black hole. And you have these two particles, and normally out in space, these particles come apart, and then they find each other, they annihilate, and then the balance is stable in the universe. And Hawking said, well, what if one of these particles appears right at the event horizon of a black hole? One goes out into space, one goes down into the black hole, and then the black hole has to give up its mass to allow these particles out into space. That is the explanation of Hawking radiation that you've probably heard. And if you explain that or talk to a physicist, a particle physicist about this, they're going to cringe, because every part of that is wrong. And even though Hawking, when he wrote A Brief History of Time and he explained this idea in that way, he knew that it was wrong, that every part of that was wrong. So I'm going to try and give you another explanation for Hawking radiation that is sort of closer to what physicists believe. And I would love, any physicists in the audience who can sort of catch any mistakes that I make, please let me know. So if you were in like an empty piece of space, if you just like removed all of the radiation and all of the matter and all of the dark matter and everything from space, you'd be left in the empty space. But space isn't empty. Space still has these quantum perturbations, these quantum fields that permeate all of space, and they're all there. They won't necessarily turn into particles and such. And you don't experience them if you're just like out in the middle of the void and all there is just these quantum fluctuations as the background of the universe. But if you accelerate in any one direction, then you do start to interact with these quantum fields. And this has been detected as a thing called Unruh. I don't know how the right way to describe it. Radiation. And so you'll actually experience a radiation in the direction that you are accelerating. It only happens if you're accelerating in any one direction. You sort of experience radiation from this. And this is coming from this quantum field, this background of the universe. And so thanks to Einstein, we know that when you are in the presence of a massive gravitational well, is the equivalent of you accelerating. And so if you were like in an elevator and you were just like free falling, it would feel exactly the same whether you in the middle of like away from all gravity and you're just sort of free falling inside your elevator, or you were like on the earth and your elevator was falling. It would feel exactly the same. That accelerating through space would feel exactly the same as you standing in an elevator and feeling the force of gravity. And so what scientists realize is that when you're in the presence of a black hole, when you get this very steep gravitational field, when you experience this intense gravity, you actually get that same radiation, the same one that you get is if you were accelerating through space itself, that they are equivalent, because accelerating through space has to be the same as being in the presence of a massive gravitational field. And so when you're near a black hole, you're going to experience radiation in the same way that when you're accelerating. And that the strength of the radiation depends on the sort of the kink of the gravity. So for a smaller black hole, one that is less massive, then you have a very steep gradient of gravity, that you go from varying levels of gravity that you feel. And that's why you can get spaghettified when you're close to a stellar mass black hole compared to when you're near, say, a supermassive black hole. You don't get spaghettified when you pass the event horizon, because the gravitational sort of effect is a lot more gradual. And so when you are near a, say, a stellar mass black hole, then the amount of that radiation, that UNRA radiation, is more intense, higher temperature. Is it starting to sound like Hawking radiation yet? Now, this radiation can't come from nowhere, right? It has to come from somewhere. How can you get this radiation that is coming from this equivalent of you accelerating? Has to come. The black hole has to give up mass to allow this radiation to be able to enter the universe, and that is Hawking radiation. All right, there you go. That is. So please let me know if that made sense to you, and if there's anything that I need to explain. Unru. There you go. So yeah, that is. So Hawking radiation, don't think about virtual particles. Think about you experiencing the equivalent of accelerating UNRU radiation when you're in the presence of a black hole. All right. That was super fun, as always. Thank you, everyone, for hanging out tonight. I really appreciate it. Thank you to John Suffield and Zapfan for gathering the questions, putting them into the database. Man, I couldn't do this without you guys. Thank you so much. I really appreciate it. Everyone give a shout out to them. It means so much. The intro is too long. Okay, fine. Yeah. Virtual particles. No, don't need to go into that much detail about virtual particles. Okay, that sounds good. Thank you, everyone. And we will see you all next week. Super fun.